Welcome back to Part 2 of Module 6, Lesson 2, One-Step Addition Equations. We're going to pick up where we left off on the Explore One-Step Addition Equations, where they want us to take and use a sketch pad to learn how to solve an addition equation using a balance. Well, that should be interesting. An equation is like a balance. A balance point represents the equal sign, and the trays represent each side of the equal sign. So we're going to take and drag a weight to one side of the balance and see what happens. And then we're going to take and use the one weights to balance out the two sides. So first off, they want us to know is how much does the x weigh. So let's take and let it load. Alright, looks like we're good here. So we're going to take the x and we're going to put that x on one side. And then it says to take and start putting ones on the other side until we end up having a level balance here. And almost there. I think one more ought to do it. Nope, I think that was too much. So I'm going to say, yeah, must be 3. So let's see if that x equals 3. And we'll check that out, and the answer checks. So you can see that on one side you have x, the other side you have 3. Kind of cute. Now we're going to do it again. We got a new x value, which appears to be heavier than the old x value. They said to do 1s, but as heavy as that one looks, I'm going to drop a 5 on there. And, well, that didn't balance it. What if I put another 5? That's going to be way cattywampus. So now let's start putting some 1s over here. And, yep, looks to me like that x is going to equal to 7 this time. And check, and that checks as well. So now we have a balanced expression that way. Look at the weights shown on the balance. What equation could be used to represent the weights? And then how could you use a balance to find the weight of one x weight? Well, here you can see that you've got x plus 3 is going to equal to the 5 on the right hand side. That would be your exact equation. X plus 3 equals 5. And then if we were to take and remove 1 from each side consistently, you're going to find that you're going to keep it balanced. And by doing that, we see that x is going to equal to 2. So from there, we can take and say 2 units, check our answer, and our answer checks again. So that equation that we created, x plus 3 equaled 5, that meant that x was equal to 2. Alright, now they're giving us a new equation down here where they've got 1x and 3 1s on the left, and then they have a 5 and 2 1s on the right. And they want us to write an equation for that. Well, that equation would be x plus 3, because you had 3 units here, is going to equal to what? 5 plus 1. Well, that's going to end up being 7. Check our answer. And then if we kept our balance being balanced, removing the same number of units from both sides, oh, that's going to be a challenge, isn't it? I think we're going to have to do some borrowing here for this one. So I'm going to start off by getting rid of that and dragging in 5 1s here, and that's going to balance it out again. So now we've got it balanced, and then I can take and remove these pieces. So 1 and 1, 1 and 1, 1 and 1, and what's left? X is equal to 3. So I'm going to say x is equal to 3 units right here. And whoops, did I not keep it balanced? What did I do wrong? Weird. Oh, I found it. 2 of my pieces were stacked on top of each other. It was like that. It was hidden. So actually, x is going to equal to 4. Going to go right there. And now I get the happy sound. Alright, that's enough playing with balance beams. The point of that lesson, though, was that if you do something to one side of the equation, you have to do it to the other side of the equation. If you don't, your equations can become unbalanced. And that's going to lead into the addition-subtraction properties of equality that you're going to learn about in this lesson.
Use algebra tiles to solve one-step addition equations. Find the value of x for the equation x plus 4 equals 7. Model the equation using algebra tiles. Place one x tile and 4 1 tiles on the left side of the mat. Place 7 1 tiles on the right side of the mat. To isolate the variable, or the x tiles, Remove the same number of 1 tiles from each side of the mat until the x tile is by itself. There are 3 1 tiles remaining on the right side. So, x equals 3. Let's try another example. Find the value of x for the equation 3 plus x equals 8. To model the equation, place 3 1 tiles and 1 x tile on the left side of the mat. Next, place 8 1 tiles on the right side of the mat. To isolate the variable, or the x tiles, remove the same number of 1 tiles from each side of the mat until the x tile is by itself. There are 5 1 tiles remaining on the right side, so x equals 5.
Now once again, they're going about showing you that if you do something on one side of that equation, you have to do it on the other side. You have to keep your equation balanced. If you don't, it's going to go off balance and then you're going to get the incorrect answer. I also like the term they use about isolating the variable. All year long, I'm going to ask you, what's the final goal of any equation? And the answer is always going to be to isolate the variable. Now, right now, they're just showing you problems, and then you get to use different toys, and then boom, you get an answer. But we're not going to be booming it in here. We're going to be using big kid math to solve this. So let's get into that. The textbook says another way to solve an additional equation is to use inverse operations, and inverse operations are defined as operations that undo each other. And we're going to go ahead and highlight that as a vocab term. When you solve an addition equation by subtracting the same number from each side of the equation, you are using the subtraction property of equality, which is another vocab term. Now let's take a look at some words here. So we're going to first off say in words, if you subtract the same number from each side of an equation, the two sides will remain equal. And we saw that demonstrated on both the balance beam they had for us, the scales, and on the algebra tiles. If they did something to one side and they did it to the other side, everything stayed equal or everything stayed balanced. Likewise, here we've got 5 equals 5, and so if you were to take and subtract 2 on both sides here and here, well, what's that mean? That means now you're going to have 3 equals 3. You could apply that by saying that if x plus 2 was equal to 3, well, you could take and subtract the 2 on the left. Because you might put that in the wrong spot. Quit it. Subtract 2 on the left, and if you do it on the left, you have to do it on the right. So we subtract the 2 on the right as well. And what's going to happen when you do that? Well, you would end up getting 3 minus 2 is 1, so your x would be equal to 1. So let's look at how we're going to solve the addition equation x plus 4 is equal to 7, but we're going to solve it using inverse operations to undo the addition by subtracting 4 from each side. So we've got the original equation right here, x plus 4 is equal to 7. From there, we're going to take and subtract 4 on the left, and we're going to subtract 4 on the right. If you do it on one side of the equal sign, you have to do it on the other side of the equal sign. From there, the 4's on the left are going to zero each other out, because 4 minus 4 is 0. That's just going to leave you with x. On the right, 7 minus 4 is 3, so x equals 3 is going to be your final answer. That is one of the good ways that you can show your work in this class. That is the vertical method. I'll also be showing you a horizontal method. Both methods are perfectly good. Both methods are excellent ways of showing your supporting work. Now it's time to look at example 2, where we're going to take the equation 8 is equal to x plus 3. And you got to remember, the final goal of every equation is to isolate the variable. The variable being x. X's friend is 3, and we have to take that friend away from him. So we're going to take and do something to move that friend to the other side, and I'm going to show you how all that's going to work. Hopefully the textbook will show you the way I want to. Now they're apparently going to give us a couple of methods. First one is going to be to use a model. So using the model, they have got, let's take a look at our equation. 8 is equal to x plus 3. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8 is equal to x plus 1, 2, 3. So that's the equation they have. 8 is equal to x plus 3. And from there, we're going to have to take and drag some tiles away from it so that we end up with a balanced equation on both sides. To do that, we're going to take the same number of tiles from each side. So the goal is to get rid of 3 tiles here so that x is all by us. We would have wants them. We don't want x to have any friends. So I'm going to take 1 and 1, 2 and 2, 3 and 3. So I subtracted 3 from both sides, and that left me with 5 is equal to x, or x is equal to 5. So what number did we end up getting right here? First it said how many 1 tiles do you need to remove from the right side? Then that is going to end up being 3. And that, of course, is going to check good. And then from there, we're going to say that x was equal to what? X is equal to 5 for our final answer. Now, that's a great visual explanation of what's going on, but it doesn't really work great in the real world because it's kind of work intensive and you're not going to really want to be drawing all these pictures and whatnot on your homework. So we really need to come up with another way, and that other way is going to be to use the subtraction property of an equality. Now, the first thing you're going to need to do is write your equation, and it doesn't matter if we're doing it here, if you're doing the practice work in the class, or if you're doing your homework. You always start off by writing your equation. If you do not write your equation, I cannot check your work properly and I will reject it and make you do it over. It only takes a moment to write 8 equals x plus 3. Alright? So make sure you're doing that. Just like they did, they wrote their equation. And then they say, well, what's the variable? The variable's x. Who's x's friend? X's friend is 3, and what is 3 doing to x? It's adding to x. So the inverse operation of plus 3, that is going to be minus 3, and you can see they've subtracted 3 on both sides. The 3's on the right are going to zero each other out. Now, back in the day, we referred to it as canceling the 3's. The high school math teachers at Gulf Shores High School's brains will explode all over you if you use the word cancel. They say cancel is not a mathematical operation, it is 0. So we are zeroing out the 3. Think about it. 3 minus 3 is 0. And in doing that, we're left with just the x on the left, and on the right, and on the left, 8 minus 3, that is equal to 5. So in the end, your answer is going to be x is equal to 5. Now, I would encourage you to take and put a line through these, and I'm going to show you how to do that when we get to our practice problem that we do together. You will do it on your own, and then I'll do it writing it down on my scratch pad. And of course, method 3 involves using the bar diagram. Nobody really wants to do this, but we're going to do it anyhow. The bar diagram, the entire bar represents the 8. We know that one part is 3, one part is x, and therefore what plus 3 is equal to 8? Well, the answer is going to be 5 there. Now, of these 3 methods, there's only one I want you to use, and that's going to be method 2. The big kid algebraic way of doing it, where you have to isolate the variable, showing me math. That's what I'm expecting to see. Alright, now it's going to be your turn. I want you to use a big kid algebraic math to solve this equation. In doing it, make sure you start off by writing the equation, you isolate the equation, doing the same thing on both sides, and you give the solid answer. You pause the video while you work on this. Alright, it's my turn to do this. I've got a problem with going twice here because I want to show you 2 different ways to skin this cat. The first method is the vertical method that they've shown. Our variable is t, his friend is 113. 113 is adding itself to t, so we're going to take and subtract 113 from both sides. When we do that, the 113s on the left zero each other out, put a line through it just like I told you to do, and what's that going to leave on the left hand side? It's going to leave t is equal to, then 175 divided by subtracting 13, well that's become a 2, a 3, and a 6. I said a 3, not a 0, and a 6, so the answer is going to be 632. That's one way to solve the problem. And that works great for whole numbers and decimals. But if you have fractions involved, you really want to use my other method, which is a horizontal way. Where here, we're going to start off the same way, only we're going to be doing our subtraction horizontally. So I took on both sides and I subtracted 113. I subtracted it right here and I subtracted it right there. Other than that, the equation's still the same. Your t plus 13 is right here. Your 745 is right here. The only thing I did is I subtracted 13 on both sides. From there, I can take and say that these two 13s zero each other out. Let me do a little better on that line. There we go. Zero each other out, and that leaves t, all by its we woulda won'tsome, is equal to the same 632 that we found the other way. So jumping back over here to our answer, it's going to be 632, I believe, is what we came up with, and check, and the answer checks. It really is that simple. This is a good spot to end this video. We only have a few resources left, but it's going to take a moment because we're getting into fractions and mixed numbers, and that's going to up the game just a little bit. So come back for part 3, and we will continue this lesson on one-step addition equations.